Recording is rolling. Today is Wednesday. We're going to do some SAT math practice. Flip my screen over. And we're doing Kahoot version. All right, you guys are logged on and ready to go. You guys got paper, pencil. This is, okay, technically non-calculator section. And I'll walk you guys through the first few because good warm-up questions. A painter will paint in walls, same size, same shape, in a building using a specific brand of paint. The painter's fee can be calculated with N times K times L times H. N is number of walls, K is dollars per square foot, L is the length, and H is the height. A customer asked for a more expensive brand of paint. Which factor would change? More expensive brand of paint. Is it the height, the length, the number of walls, or maybe dollars per square foot? You guys like dollars per square foot? One of you did. Yeah. 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 Oh, okay. Yeah, that one's pretty fast. Okay, so dollars per square foot, that constant. Leave those. If 3R equals 18, what is 6R plus 3? So you could say R is 6, and 6 by 6 is 36, plus 3 is 39. Or you could say 6R, hey, that's double the original 18. Then plus 3, 36, 37, 38, 39. 39. Oh, look at you guys go. Yeah. What is equal to a to the power of 2/3? Whenever you see a fraction power like that, remember the numerator refers to the usual power, or a squared, but that denominator 3, that's like a cube root, right? So the denominator of the fraction of the power, in this case 3, that's like a root, in this case cube root, okay? So a squared, the cube root of that. Number of states that joined the United States between 1776 1849 is twice the number of states that joined 1850 to 1900. If 30 states joined 1776 1849 and X states joined 1850 to 1900, which of the following equations is true? The way I would do this personally is just solve for X and see which equation is consistent with that. So if there was 30 states originally, and it was twice of X, then wouldn't X have to be 15? So they're originally 30, and then later on there were 15. Right? I'm looking at choice B. 2 times 15 is 30, right? That can do it. So sometimes SAT will ask you a question where they don't want you to solve all the way for X, but they want you to set up an expression that could solve for X. This is that category question. But sometimes the easiest way is just to solve for X anyway and see which equation would be consistent with that. So yeah, so X would be 15. There were originally 30 states. Later on, there were 15. That's a 2-to-1 ratio. 2X equals 30. That'll do it. If that fraction equals that fraction, what's the value of X over 5? So go ahead, solve for X and then figure out X over 5. All right, so flip the screen over and solve this one out with you guys. Because this one definitely takes some paper, or at least for me. Right, so they gave you this setup and it said, what is x over 5? Now, my first thought was, oh, x over 5, that is the reciprocal of this. I wonder if there's an answer choice that says x plus 20 all divided by 15. There was not. All the answers were just numerical answers. Okay, so I guess we do have to solve for x at some point. So different ways you could do this. What I did is I cross multiply x times 15 and x plus 20 all times the 5. You can cross multiply across that equal sign, right? Okay. And that made it look like this, right? Cross multiply, is that okay? Okay, then distribute. So this 5 applies to both the x and the 20. So that looks like that. Is that true? Okay. Then I see 3 terms, 2 of them have the x, so I'm going to subtract the 5x over and get that line. Divide both sides by this coefficient 10. 100 over 10 is 10. Okay, so x is 10. Okay, but they didn't actually ask for x. They asked, what is x over 5? So then you take this substitute, and then the answer was 2. Okay. You guys have seen some questions like this? Sometimes they like to do it with coordinates. Like if there's some xy coordinate, they'll say like, what is x times y? What is x minus y? Right. So you have to solve both and then do one last little expression at the tail end to get to the answer. So that can happen. Share screen through. System of equations. Oh, there you go. What is x minus y? All right. Hold on. I wonder if I copied this down wrong because I must have made some mistake. Let's see. I was trying to work it out with you guys too. All right. This is number 6. That minus that is that. That minus. I did miss a sign. Okay, that's right. So I flip over and I'm going to start over. Show what I did here. Okay. So I copied this down wrong, which caused me to mess up. But right. This should have been a negative. Okay, so that was the original statement right there. Okay. Now, system of equations. There's different ways to solve. You could do substitution. You could do elimination. You guys see, I was trying to set up elimination here, right? Because I took the whole top one, put it in brackets, and multiplied by this factor. Now, can you guys tell what variable I was trying to eliminate? If I multiply by -3 over 2, isn't this coefficient 2 going to turn to a -3 on this x? Which would cancel out with this one. Okay, so let's do that. Let's distribute this -3 over 2. This is just one way to solve this. Okay? That gives me -3x. Then if you distribute this in here, that's plus 9/2 y. That's equal to now half of 14 is 7 times 3 is 21, and the sign switches. So then I'll just copy paste the bottom equation. Okay. But -2, I'm going to change that to -4/2 just so it aligns with this. Okay, now if I add those two equations up, the x's go away, but it was set up ahead of time so that would happen. This is 5 halves y is equal to 15, right? Is that? Now, cross multiply 2, divide by 5. 2 times 15 is 30, divided by 5 is 6. So y is equal to 6. Okay. Now, I solved y first in this case. You could have solved x first, but either way, you're going to have to get x. So x, you can go back to any previous equation and solve for x. Let's say like this one right here. So if y is equal to 6, right? 2 times 6 is 12. So you're subtracting 12 here. If you add 12 over, guess what is 12 minus 6? It'd be 6. So at some point I'm getting 3x is equal to 6, divide both sides by 3, x is equal to 2. Okay, so I got x is 2 and y is 6. Is that? Okay. Not the only way to solve that. There's a bunch of ways to solve it, but at some point you should have come across this. The actual question was, what is x minus y? So here's your x, 2, here's your y, 6. 2 minus 6 is -4, and that was the answer. The answer was actually -4. Okay. That's good. Okay. So yeah, a little complicated one, but all right. Flip back over. All right, so you get an XY table. There's some points that are plotted. It says it's some polynomial, and some values are shown. What must be a factor of f of x? Okay, now, if you know what's going on, go for it. If you're totally confused, then here's what they mean. There are different ways to write polynomials. One way you can write is in terms of factors, like x minus 3 times x plus 2 times x minus 7, right? You could multiply a bunch of factors together like that. And the advantage of doing that is that you can very quickly pick out the x-intercepts, because you can see, well, you'd see what would set to 0 to make the whole thing 0. So if you can find an x-intercept according to that table of data, then what factor would lead to that x-intercept? It's one of those answer choices. You guys see this row right here, the coordinate 4, 0. Doesn't that represent an x-intercept? Right? So the factor associated with that would be x minus 4. I flip over my screen and show you guys why. So I know I did a verbal explanation, but I'm just going to write this out so you guys can see this. Talk about here. So one way you could write polynomials would be like y equals x cubed plus 7x squared minus 3x plus 10 or something. But another way you could write it is in terms of factors. So you could do like, I'll put, let's say x plus 7, x minus 1, x minus 4, maybe something like that. Okay. Now, of course, if you wanted to expand that out again, x cubed plus blah, 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 you could do that too. Okay. But this form, the advantage is that you can pick out the x-intercepts real fast. Okay. So watch this magic. Like, for example, what if x was equal to -7? Wouldn't this little piece go to 0? And then 0 times the whole thing would just be 0. So here at -7, there is a point on this, whatever this crazy curve looks like, that is one of the points. Okay. How about if x is equal to +1? Wouldn't that also 0 out this and therefore 0 out the whole thing? So +1, there's the point, and also +4, which is right about here. Hey, you guys see that? So what does this polynomial look like? I don't know exactly, but I bet it looks a lot like this. Probably something like that. I mean, it is a cubic, right? Got an x cubed involved, something like that. Okay. And okay, so that's what they were saying. The fact that one of the x-intercepts on their own example was 4, 0, right? Now the other points they gave were not intercepts; they were just like random points, like this point or this point. But they gave you an x-intercept. You know that x minus 4 could be a factor of that polynomial. You guys figured that out. The line kx plus 4, where k is a constant. Okay, so we don't know the slope, but we do know the y-intercept. It's on the xy plane. The line also contains the point CD. What is the slope of the line. So what is K? Draw this one out. If you draw it out of it, you guys can get it. All right, let's switch over and that's what's going on here. Switching color here. And so kx plus 4. I don't know what that line is because k could be anything at this point, but it does have to go through the 0.04. Okay, so it might look like that. It might look like that. It might look like that. I mean, it could be a lot of things, right? But it does have to go through this point. So all those red lines are possibilities for that setup. But they also told you there's a point CD, maybe like this point right here. This might be the point C comma D. Okay? So the x-intercept would be C, or sorry, the x coordinate would be C and the y coordinate would be D. Okay. All right, so that might maybe refer to this red line. Okay? That's the one I'm interested in. So what's the slope? The slope would be K, okay? But wouldn't that be rise over run? So here's the rise and here's the run between these two known points on that line, right? The 0.04 is the 0.04, this point CD, right? So what's the rise equal to? D minus 4. What's the run equal to? C minus 0. So the slope, which is K, is D minus 4 all over C minus 0, or just call it C, and that's the answer. That's the answer. Let's get that. System of equations. K is a constant, x and y are variables. For what value of K will the system have no solution? Here's a hint. It would have a solution if those lines crossed. It would not have a solution if those lines were parallel somehow. All right, have you guys figured it out? So flip the screen over and show you guys how to solve this. Now, the general principle is like this. If you want to solve a solution, based on like two lines, normally you get like two lines that do something like this. And the solution is just wherever they cross. There's an x coordinate, there's a y coordinate, x equals something, y is equal to something. Okay? But if the lines were parallel, like here, they would never cross, so there would never be a solution. So if you, so how can you get that? Now, they did give the equations in standard form instead of slope-intercept form, so because we're looking for the same slope, that would make parallel, right? The way you can get it from standard form is if the ratios of the coefficients are the same in front of x and y, that would indicate parallel lines. So for example, if you look at the y term, see how it expands from 3 to 5? So it expands by 5/3, going from the top equation to the bottom equation, expands by 5/3. Right? If the x coefficient expansion also increases by 5/3, then either the two equations would be the same line, or they would be parallel and there would be no solution. Right. And I do see that going from 4 to 7, that is not an expansion of 5/3, which tells me that it would fall into the parallel situation. Right? So if you take k and multiply by 5/3, that should give you 4. Or that would be the case to give you parallel lines. Okay? See the y coefficient expanded by 5/3. So if k does the same thing to get to 4, then that would be the situation we're looking for. Okay. So what is k is the question for. Okay. So cross multiply of 3, 4 times 3 is 12, divide down 5. K is 4 times 3 is 12 over 5, 12 is. That would give you parallel lines. And one way to solve that. X by playing a parabola with that equation intersects that line at 2 points A and B. What is the length AB? Okay. Give you guys some hints. The second equation is just a horizontal line. And that parabola, that whole minus 11 just shifts it horizontally, which may not affect the answer. You get it from there. Okay. This is pretty tough. So put the screen over. Once you guys see the picture, though, it's like, oh, okay, I see why that's the case. So, but I gave you these two equations. It said these intersect at 2 points. What's the distance between the 2 points? Okay. Now y equals 25. Isn't that just a flat line at y equals 25? Okay. So got a coordinate up here at 25. Right? And y is always 25, independent of what x is. That's why there's no x in this equation. Y is always 25. Okay. Now the other one, actually I'm going to start by graphing something a little bit different. I'm just going to graph y equals x squared. Y equals x squared. Does that look something like this? Y equals x squared. Wouldn't that be true? Okay. And the whole minus 11, all that does is just shifts it to the right 11 units. Wouldn't that look something kind of like this? Y equals x minus 11 quantity squared. Okay. Okay. But whether or not you apply that shift, you guys see that the distance between the two intersecting points is this the same regardless? Okay. Same distance, right? Okay. And what is that distance? What are these coordinates? Let's go back to the simplified version, y equals x squared. Okay. Who can tell me what is this coordinate right here? 5. Yes, because y equals x squared, 5 squared is 25. Right? And what's this coordinate right here? Negative 5. And what's the difference between 5 and negative 5? 10. And that's the answer. The answer is 10. Okay. And even if you apply the horizontal shift, the distance would still be 10. Okay. KLM, all those lines intersect. If x plus y, so these two wedges put together, is equal to u plus w, these two wedges put together, what must be true? Two of those statements are true. Which two statements are true? All right. Flip over. All right. Now, in their original picture, these wedges looked about 60 degrees each, but that may not necessarily be true. Like, what they did say was that these two angles put together, whatever angle that is, that's the same as these two angles put together. Okay. That's what they gave you. Okay. Now, if that's true, can you guys see that it would also be true that this angle is equal to this angle? Right, that would be true. Right. Okay, so that could be like one possibility. But if that's true, and then this angle is equal to this angle, so that would also be true, right? In fact, these four angles are always going to be the same, right? And one thing you can do to check that is, because remember, these wedges may not necessarily be exactly 60 degrees, but you can make up your own variations on the scenario as long as it matches the initial condition. For example, you might have something like that, or you might have something like this. And the original condition would still be met, right? That these two wedges is equal to these two wedges put together, right? But whatever crazy scenario you come up with, these four angles are always equal to each other for the scenario that they gave you. Right? Now, if you can figure that out, then I think it was options 1 and 3. So statement 1, statement 3, that said something along those lines. Yeah, so the takeaway is, yeah, if you can manipulate, in your mind, say, well, what if I shift this line this way so it's still consistent with what they gave me, but it's still universally true? Quadratic equation above has a vertex CD. So the parabola has a vertex. Which of the following is equal to the, well, D, which is the y coordinate of that vertex? I'll walk you guys through this one. Because the form they gave it to you in is, you guys see that they're going to be intercepts at the point 20 and -40. You guys see that? And because the parabola has symmetry, shouldn't the vertex be exactly halfway between those 2 points? What is exactly halfway between +2 and -4? About -1, right? Now that's just the x coordinate. Let's plug in -1. So I got -1 minus 2 is -3. -1 plus 4 is +3. 3 times 3 is 9, times a is, right? You guys see the answer? And that's the y coordinate. Now that a is just a vertical stretch factor. So if you toss that out, you can put back in it. Yeah. So there you go. So the answer is A. Oh, whoops, wasn't sharing my screen. Yeah, that's good. I'll flip over. Well, if you're watching the video at home, so sorry I wasn't sharing my screen on that, but it was something like this. Y equals stretch factor times what was it? X minus 4, x plus 2, or no, x plus 4, x minus 2, something like that. Okay. We're saying what's the vertex of that parabola? Okay. Now the trick I just took you guys through is that this has an intercept at -40 and a +20. That's at -4 and +2. So if the parabola looks something like this, then that vertex must have an intercept halfway between these two numbers, which is at -1, because 3 units here, 3 units here. Okay. But the question is, what's the y coordinate of that? Okay. So you take that -1, you plug it into here and here, and it comes out to -9 times this vertical stretch factor a. So the answer was -9a. Okay. Now, what's another way you could have done about it? You could have multiplied this out. So a times, let me FOIL all this part right here. I'm just going to FOIL this part. FOIL. That would look like that, right? Okay. And do you guys know the rule for the x value of the vertex from this form? It's a piece of the quadratic formula, not the whole thing, but it's the part that says -b/2a. Okay? Let's see if that actually works. So this is ax squared plus bx plus c. I mean, not this a, but a general a is equal to 1 in this context. A squared plus bx plus c. So -b, so that's -2 divided by 2 times an applied 1. Oh, that is at -1, right? Just like we were saying before. So it's a different way to get there. Do that. What are the solutions to that? Quadratic. Two. Okay. Pretty tough. Well, probably just need more time. I think if you guys had more time, we would have got that. And so walk you guys through the solution over here. So they gave you this. Now, one thing I noticed is that these are all multiples of 3, so I just factored a 3 out. You don't have to do that, but I think it makes everything else a little bit easier to work with. Now, next thing I thought is like, oh, okay, so I'm ready to factor this. So x plus something, x plus something. But then if you try that, you probably realize, okay, that doesn't factor very nicely. Also, all the answer choices didn't look like integers. So quadratic formula, we're going to make a quadratic equation out of this. Probably good to memorize for the SAT, right? Might pick up some points. So remember, this is pre-solved. The 3 I can just divide out. So whatever, just ignore that. So I'm going to use ax squared plus bx plus c is equal to 0. My a is 1, my b is 4, and my c is 2. So I got negative b plus or minus square root of b squared minus 4 times a, implied 1, times c, all divided by 2a. Okay, so have that memorized going into SAT next week, right? Because good chance you have. Right. Then that looks like this. I broke it apart into 2 fractions. Negative 4 over 2, of course, is 2. But square root of 8, you can actually simplify. Because square root of 8 isn't that the square root of 2 times 2 times 2? So if you have a square root of a pair of numbers, and there's like 3 2s, so you can take 2 of those out. You can bring out in front. Then, since you're divided by 2, well, this cancels, and this is the answer. That was the answer they were looking for. Okay, so the temperature in Celsius is equal to 5/9 Fahrenheit minus 32. Which statements are true? A temperature, give you guys a hint, out of these 3 statements, 2 of these are, oops, sorry. All right, let's go through one. Temperature increase of 1 degree Fahrenheit is equal to a rise in temperature of 5/9 degrees Celsius. That checks out, right? Because change of 1 Fahrenheit times 5/9 would be 5/9 increase in Celsius. Option 2, a temperature increase of 1 degree Celsius is equivalent to a 1.8 degree Fahrenheit increase. That's also true because that would be 9/5. 9/5 is the same thing as 1.8. So if you had a 9/5 increase in Fahrenheit, that's the same thing as 1 degree increase Celsius. Okay. What about that last statement? Statement 3, a temperature increase of 5/9 degree Fahrenheit would be a change of 1 degree Celsius. Because I can tell you what it would be. It would be, if you increase Fahrenheit by 5/9, that'd be 5 times 5 is 25 over 9 times 9 is 81. That'd be an increase of 29 over 81 in terms of degrees Celsius, which is not what we're looking for. Right. So those first 2 statements, check out. Only those 2. This is actual, if you guys ever travel overseas or you're used to one system and not the other, say you wake up in England and it's like, oh, it's a nice 18 degrees outside. Like, what the heck does that even mean? Right? You could use that equation. Well, let's go from Celsius back to Fahrenheit. Actually, you have to manipulate the other version. Do you guys know the shortcut trick? That's a pretty good approximation. Going from Celsius back to Fahrenheit. I know it's opposite of what they were saying there. If you double, because double is pretty close to 9/5, isn't it? right? This is pretty close to 2. Okay. And then that intercept factor of 32, because you guys know 32 degrees Fahrenheit, same thing as 0 degrees Celsius. So treat that like y-intercept. Well, that kind of rounds to about 30. So a factor of 2 overestimates a little bit. 30, if you add 30, that underestimates a little bit. Right? So it's 18 degrees outside. Like, okay, so 18 times 2 is 36 plus 30. You say, okay, probably about 66 degrees Fahrenheit, maybe somewhere in there. Okay, so you get an idea of what that means. Little side thoughts. That equation, what is one possible solution? So 2 correct answers, 1 and 2 each work. I think this is one of those questions, probably be good to start from the answer choices and just plug them in and see what happens. So let me try that over here. So, truth be told, I've not gotten this far into this Kahoot yet today, so uncharted territory. So this is what they gave us. I guess you could just plug stuff into there. 1 and 2 should each work. I did a little manipulation. I just distributed this and got this, right? And then added the 4x over, right? You could take an x out of each of these. Okay, I don't know if that really helps, but supposedly the answers are 1 or 2. Let's plug in 1, see what happens. So if you plug in 1, okay, so this is just 1, so whatever. 1 to the 4th is 1, minus 5 plus 4. That would be 0, wouldn't it? Because so 1 works. Right? Or x could be equal to 2. Let's see, 2, 4, 8, 16. So this is 16, right? 2, 4 times 5 is 20. So 16 minus 20 is negative 4. Oh, plus 4 is 0. Hey, it checks out. Okay. And then even if you multiply by 2, still works. Okay. You guys want to see another way to solve this? All right. Remember that whole thing about factors? Right? I mean, if x could be equal to 1, do you think I could factor x minus 1 out of this? Okay. I bet I could. Let's do some long division. I want to take it that way. X to the 4 minus 5x squared. I'll just do the piece in parentheses. Plus 4. Right. Let's do long division. I'm going to factor out if 1 was a possible solution, I'm going to do x minus 1 because 1, if you plug in 1, it would bring it to 0. Right. And then if this truly is a factor, if this works, then I should end up with no remainder. Right, so I see x cubed times x is x to the 4 minus, x cubed. Right? So subtract this off. That gives you positive x cubed minus 5x squared plus 4. Right? Next thing I see, let's go plus x squared. So x squared goes into here, x cubed minus x squared. Subtract this off. That looks like, 5 minus negative 1. 5 plus 1, that's negative 4x squared, then plus 4. I see you could do minus 4x. Yeah, minus 4x. And so that brings you to negative 4x squared plus 4x. Okay, well, you can keep going on like that, but actually, we're real close. I'll just continue over here. Okay. So subtract this. I get negative 4x and then plus 4. Okay. Then I can do minus 4 because 4 times x would be negative 4x. And then negative 4 times negative 1 is positive 4. Subtract 0. Right. The fact that there's no remainder means that this times this brings you back to the original statement. Okay, and then you could also factor out an x minus 2, and that would also work. So a little bit overkill on that one, but all right. Okay, what is the value of X? All right, you guys got it. So switch your screen over. Get this one. Well, one thing I see right away is that there's already a common denominator on the X side, so just tag those together. 7 minus 4 is, and then over here, maybe common denominator would be 12, so I can multiply this one by 3 over 3, right? This little 3 over 3 here, right? To align those denominators, so they're both 12. Okay. So that gives me on the left side 7 minus 4 is 3, so 3/9 X, and on the right side, that'd be 3/12 plus 5/12. Okay. Okay, now 3/9 X, that reduces to 1/3 X. And this, of course, is 8/12. But 8/12 also reduces, doesn't it? To 2/3, if that helps. Multiply both sides by 3, or the 3 cancels. Either way you think of it, X is 2. And that was the answer. Okay. Guess what there? Okay. I'm gonna walk you guys through this one because this will be the last time we have time for today. Okay. I like this one too. If 180 minus z is equal to 2y and y is equal to 75, what is the value of x? It looks like crazy geometry, but if you figure out one thing, well, if you guys know all 3 angles of a triangle add up to what? 180 degrees. Right. Now take a look at this right here. 180. 180. Minus z is equal to 2y. Hey, do you think that this little corner here and this little corner here are each equal to y? Right? Because if you take 180 degrees and subtract out z, and that leaves you with 2y, then this would have to be y and this would have to be y. Right? Make sense? And if that's true, we're trying to figure out x. Here's 180 degrees. 180 minus 75 is 105. The answer is the red one. Yeah. So there's our winners. We've got Liam Payne, a blushing snail, something in Japanese, Alicia and Ian. We are winners. Thank you for playing. You guys have a good rest of your day.